Hello friends, how are you? In this video lecture of chemical kinetics, today we will see what is second order reaction, examples of second order reaction, integrated rate law in second order reaction, unit of rate constant in second order reaction, half-life period in second order reaction. So to understand this, watch this video till the end. अगर आपको पसंद आता है तो like it, comment it, share it and subscribe it. So what is second order reaction? A reaction in which rate of reaction depends on what? Concentration of two reacting molecules or square of concentration of reacting molecule when concentration of two reactants is same. Here are two cases. When concentration of two reactants is different, in case number 2, when concentration of two reacting molecules is the same. So, this is second order kinetics. Example of second order kinetics, decomposition of nitrogen dioxide. Iska decomposition. So here formation of nitric oxide and oxygen gas is released. So here a rate of reaction is directly proportional to concentration of what? Nitrogen dioxide. इसका स्क्वायर है. So what is the order of reaction? Second order reaction. Decomposition of nitrosyl bromide. इसका decomposition. So here formation of nitric oxide and bromine is released. So rate of reaction is directly proportional to concentration of what? Nitrosyl bromide. इसकी power 2 है. So that is why second order kinetics. Decomposition of hydroiodic acid. Here hydrogen gas is released and iodine is formed. So here also rate of reaction is directly proportional to concentration of what? Hydroiodic acid to the power 2. And order of reaction is 2. Alkaline hydrolysis of ester. Alkaline hydrolysis of ester. Here formation of sodium acetate. Alcohol is given out. So here rate of reaction is directly proportional to concentration of ester and concentration of base. That is why this is an example of second order kinetics. We have seen ester hydrolysis in acidic medium. That was an example of first order kinetics. It was an example of pseudo first order reaction. Because in that reaction, rate of reaction depends on concentration of ester only. क्योंकि उसमें water excess है. And we know that rate of reaction is independent on that reactant whose concentration is in excess. So all these are the examples of what? Second order kinetics. So what is second order reaction? A reaction in which rate of reaction depends on what? Concentration of two reacting molecules or square of concentration of reacting molecule. So this is second order kinetics. Now integrated rate law for second order kinetics. See here, suppose reaction is A plus B, it gives product. A reaction है. This is actually general reaction. यहाँ पर A and B, these two are reactants and P is the product. Suppose initial concentration of A is A and again initial concentration of B is also A. Concentration of product will be 0. यहाँ पर मैंने क्या किया है? Here I have taken concentration of A is equal to concentration of B. Here two possible cases are there when concentration of A is equal to concentration of B and concentration of A is not equal to concentration of B. So here I will explain when concentration of these two reacting molecules is exactly same. So here A is the initial concentration of these two reactants. After certain time t, suppose X is the concentration of product. तो A का concentration क्या होगा? A minus X होगा. B का भी concentration क्या होगा? A minus X. After certain time, when time is 0, then concentration of capital A, it is small a. concentration of capital B, second reactant, it is small a. Concentration of product will be 0. But after certain time, when reaction in progress, after certain time, suppose concentration of product is X, then concentration of A, it will be A minus X, and concentration of B, again it will be A minus X. Now, what is the rate of reaction for this equation? Rate of reaction, decrease in concentration of what? Reactant per unit time, and minus dA by dt. We have seen the definition of rate of reaction. This negative sign indicates what? Decrease in concentration. dA by dt, dt and a time interval, dA and a change in concentration. So here about second reactant B, exactly same, that is minus d by dt of what? Concentration of B. This is the rate of reaction. So what is the concentration of A after certain time? A minus X. B का भी concentration क्या है? A minus X. And the same you can write R is equal to minus d by dt of A minus X, or minus d by dt of A minus X. Equation number 1. Negative sign indicates a decrease in concentration. Rate of reaction and velocity of reaction, decrease in concentration of reactant per unit time, or increase in concentration of product per unit time. Now, what is the rate law for this equation? We know that what is the rate law? It is simple mathematical equation in which rate of reaction is expressed in terms of concentration of reacting molecules. So here, a rate law R is equal to K into concentration of A and concentration of B. After certain time, what is the concentration of A? It is A minus X. Concentration of B, again A minus X. And a same equation we can write R is equal to K into concentration of A minus X into concentration of B, and A minus X, and it is square of A minus X. Equation number 2. Now compare equation number 1 and 2. I will take the concentration of A only. I can take concentration of either A or concentration of B. So here, by comparing these two equations, left hand side is the same. Therefore, we can write minus d by dt of A minus X is equal to K into A minus X to the power 2. Now evaluate this. ये क्या होगा? माइनस डी ए बाई डी टी, माइनस माइनस प्लस होगा, डी एक्स बाई डी टी is equal to K into A minus X square. अब ये कांस्टेंट है. इनिशियल कॉन्सेंट्रेशन ऑफ रिएक्टेंट इज द कांस्टेंट, X इज वेरिएबल. कांस्टेंट का डेरिवेटिव 0 होता है, यानी माइनस डी ए बाई डी टी, ए टर्म 0 होगी. देयरफॉर सेम इक्वेशन वी कैन राइट डी एक्स बाई डी टी is equal to K into A minus X to the power 2. Equation number 3. Now by rearranging this equation number 3, we can take concentration terms to one side, yani it will be dx by A minus X square equal to K into dt. Here I will take K2. Everywhere I will take K2 because this is an example of second order kinetics. For our simplicity only K2 into dt. Equation number 4. Now integration of this, by taking integration of equation number 4, integration of dx upon A minus X to the power 2 equal to a K2 constant है, so we can take outside of the integration K2 integration of dt. Now what is the integration of dx upon A minus X square? इसका इंटीग्रेशन ऑफ x टू द पावर n, इसका इंटीग्रेशन होता है x टू द पावर n प्लस 1 डिवाइडेड बाय n प्लस 1. व्हाट इज द इंटीग्रेशन ऑफ x टू 1 अपॉन x टू द पावर n? फॉर 1 अपॉन x टू द पावर n वी कैन राइट x टू द पावर माइनस n. तो इसका इंटीग्रेशन क्या होगा? x टू द पावर माइनस n प्लस 1 डिवाइडेड बाय माइनस n प्लस 1. एग्जैक्टली सेम है. फॉर दिस वी कैन राइट a into a minus x to the power minus 2 into dx, isn't it? K2. Now, what is the integration of dt? Derivative and integration opposite. So, ये कैंसल होता है, यानी इट इज ओनली टी प्लस सी. ये सी क्या है? इंटीग्रेशन कांस्टेंट है. नाउ व्हाट इज द इंटीग्रेशन ऑफ दिस? a minus x to the power minus 2 plus 1 divided by minus 2 plus 1. नाउ इसका इंटीग्रेशन जब होता है तो a माइनस x का कोएफिशिएंट क्या है? -1 है. सो हियर वी हैव टू राइट दिस -1 आउटसाइड ऑफ द इंटीग्रेशन. -1 a minus x to the power minus 2 plus 1 divided by minus 2 plus 1 is equal to k2t plus c. अब ये माइनस बाहर है. नाउ a माइनस x -2 plus 1 -1 होगा. -2 plus 1 -1 इक्वल टू k2t plus c. अब ये माइनस माइनस प्लस होगा and it is simply a minus x to the power -1 is equal to k2t plus c. And a minus x to the power -1, and the same equation we can write 1 upon a minus x to the power 1 equal to k2t plus c. Equation number 5. Now from this equation number 5, suppose time is 0. तो concentration of what? X will be 0. जब टाइम 0 होगा तो प्रोडक्ट का कॉन्सेंट्रेशन 0 होगा. सो दिस इक्वेशन 5 विल बी 1 अपॉन a माइनस एक्स. a माइनस एक्स यानी x क्या है? 0 है. यानी 1 अपॉन a इज इक्वल टू k2 इंटू टी. टाइम 0 है यानी k2 इंटू 0 a 0 होगा. सो प्लस c. इक्वेशन नंबर 6. नाउ पुट द वैल्यू ऑफ दिस कांस्टेंट c in equation number 5, and from equation 5 and 6, equation 5 will be 1 upon a minus x is equal to k2t. अभी c की वैल्यू क्या है? What is the value of c? It is 1 upon a. Same equation you can write. I will take concentration terms to one side. यानी 1 upon a minus x, इधर प्लस है, it will be 1 minus 1 by a equal to k2 into t. Now after simple calculation by evaluating this, a into 1 a minus 1 into a minus x upon a into a minus x, we can write like this k2t. अब इसको इवेल्युएट करो. a minus a minus minus plus x divided by a into a minus x equal to k2t plus a minus a, it will be cancelled. So equation we can write x upon a into a minus x is equal to k2t. Therefore k2 is equal to 1 upon t a into x upon a minus x. So this is integrated rate law for second order kinetics. K2 is equal to 1 upon t into a into x upon a minus x. So this equation is said to be integrated rate law for second order reaction. Now unit of rate constant in second order reaction, here equation is K2 is equal to 1 upon a into t into x upon a minus x. अब इसका यूनिट निकालना है. सो यूनिट ऑफ K2, इसका यूनिट 1 अपॉन a कॉन्सेंट्रेशन है, कॉन्सेंट्रेशन, t इट इज अ टाइम, इंटू x क्या है? इट इज द कॉन्सेंट्रेशन ऑफ प्रोडक्ट, यानी कॉन्सेंट्रेशन टर्म है. a माइनस एक्स, ए भी कॉन्सेंट्रेशन टर्म है. concentration cancelled, and what is unit? 1 upon concentration into time. What is the unit of concentration? Moles per dm cube we can write, यानी moles per dm cube per dm cube, and it will be dm to the power -3 upon time, isn't it? So same equation you can write, a moles inverse होगा, inverse dm to the power 3 होगा into time inverse. So this is the unit of rate constant in second order kinetics. Now what is the half-life period in second order kinetics? Again I will take that equation K2 is equal to 1 upon AT into x upon a minus x. So I will take this time to this side and equation will be t equal to 1 upon ak2 into x upon a minus x. यहाँ पर हमें निकालना है हाफ लाइफ पीरियड यानी t विल बी व्हाट, यहाँ पर t क्या होगा, t इट विल बी t हाफ एंड x क्या होगा, a/2 होगा, a/2. हाफ लाइफ पीरियड यानी टाइम रिक्वायर्ड टू डिके इट्स हाफ. So here time is equal to t half, x it will be an a/2, where a is initial concentration. After t half it will be a/2, so x will be a/2. So by putting these values in this equation, yani t half is equal to 1 upon a into k2. अभी x क्या होगा, a/2 होगा, a minus a/2. By evaluating this equation, 1 upon ak2 into a/2, a minus a/2 इसका कैलकुलेशन होगा a/2, because 2a minus 1a divided by 2 यानी it will be a/2. So this a/2 it will be cancelled. Therefore t half is equal to 1 upon a into k2. So we can write half-life period in second order kinetics is directly proportional to 1 upon a, and here a to the power 1. Same equation, we can write that a to the power minus 1. In numerator, it will be e to the power minus 1. And a half-life period is inversely proportional to what? Concentration of what? Reacting molecule. So this is half-life period. T half is equal to 1 upon a into k2. And here half-life period is inversely proportional to what? Concentration of reacting molecule. So this is half-life period, unit of rate constant in second order reaction, examples of second order reaction, and integrated rate law of second order reaction when concentration of reacting molecules same. In next lecture, we'll see another expression, that is derivation for second order kinetics when concentration of reactants are different. If any doubt, you can put your doubt in comment box. Definitely, I will get back to you. Thank you.